Howdy and welcome back. So I want to introduce this idea of finding a node successor. And a node successor is going to be essentially defined as the node that would come after that node had we been performing an in-order traversal on our binary search tree. So an in-order traversal here would just be 4, 8, 10, 12, 20, 22. I didn't miss any here, did I? Got 4, we've got 8, we've got 10, we've got 12, 20, 22. Cool. So we got them all. If I asked you what 4's successor was, what comes after 4 in our in-order traversal would be 8. So 4's successor is 8. If I asked you who 8's successor was, you'd say 10, because that is the node that would come after the node with the key value of 8. If I ask you who 10's successor was, would be the node with the key value of 12. Because again, that node would come after our node with the key value of 10 had we been performing an in-order traversal on this. Okay, who's the successor to 12? 20. Who's the successor to 20? 22. What do you notice here? Well, finding 4's successor was kind of easy, right? Or was it? What did we have to do to determine that it was 8? Well, remember, an in-order traversal is first going to go left, then visit the root, and then go to the right subtree. So if we're at 4, we'd attempt to go left. Can't go that way, and 4's successor isn't going to be to the left because that would be less than 4, right? We're looking for the node that comes after it. So in our in-order traversal, we're back here at 4. Now we try to go right. If there was a 5 here, or 6, or 7, notice that 4's successor would have been the node with the key value of 5. But that wasn't the case. So then where did we check? Well, its parent, 8. Cool, so that kind of makes sense. But what happens if we're looking for 8's key value or successor? Okay, well, we know it ain't going to be to the left. Could it be to the right? But what's the problem if we step right? Is it just going to be this node? Let me use a different color. Y'all know I like my colors. Is it going to be this node? Well, maybe, but the problem here is that it has a left subtree, which means that the values to the left of 12 are going to be less than 12 and therefore closer to 8. Okay, so maybe that's making a little bit of sense. And if not, don't worry, I have an example with some beautiful diagrams I put together. Let's say we're looking for 12 successor. Nowhere to go to the right. So how do we know who its successor is? If we go up, notice that 12 is to the right of its parent, right? So in that case, because it's to the right of the parent's key value is going to be less than that of 12. So we're going to have to go up again. How do we know when we find 12's parent? Or sorry, successor? Well, we're going to have to keep going until we find the point where the node parent has the node who we're looking for its successor in its left subtree. So look at 8. 12 was in its right subtree, right? So it guarantees that 12 is bigger than 8. But if we get to a node and the node whose successor we're looking for is in its subtree, we know that that node there is going to have a key value larger than the node under consideration, or the node whose successor we're looking for. And at that point in this kind of in-order traversal process, we've isolated 12's successor, 20. So let's If that doesn't quite make sense, let me try to build it up here. But here's the kind of motivation here. What if we'd like to find a node successor in the binary search tree as it would be determined by an in-order tree walk? The successor to some node X is the node with the smallest key greater than X's key. And here's the algorithm over here on the right, and we'll begin walking through it here or here. So there's going to be 3 conditions here, and I'll go ahead and focus on the first condition first. We'll get into the second condition, and then we'll close out with the third. So we're looking for 8's successor. Condition 1 is going to be to see whether the node, so in this case, the node with the key value of 8, has a right subtree. If it does, we know that the node with the key value of 8's successor is going to be the minimum node of its right subtree. So look here, we simply return the tree minimum. So that's that minimum function we wrote earlier today of nodes right. So we invoke minimum on this function right here. Sorry, not this function, that node right there. We calculate the minimum there, and guess what? It is the node with the key value of 10, which would be the successor to our node with the key value of 8. And this is by the property of our binary search tree. Okay. So just stepping through this, we look at the node 12. We're going to compute its minimum value. So stepping through, and we eventually arrive at 10. So 8's successor is 10. And again, we can just confirm that by performing an in-order traversal on this tree, which would be 4, 8, 10, 12, 14, 20, 22. And based off of this, we have successfully found 8's successor, which is 10. Okay, let me copy and paste this onto the next slide because the next condition gets a little bit more interesting. So let's say we want to find the successor of 10, which is going to be 12 here. The first case is to check to see whether or not this node with the key value of 10 has a right subtree. Because if it does, by definition, its successor is going to be the min of the right subtree, the node with the minimum key value of the right subtree. Here, there is no right subtree. So how do we determine what its who its successor is? We know that it's 12 just based off of whatever to now, but how do we compute that? So we're going to create a node pointer successor, and we're going to point it to the parent. So here's successor, and here's going to be our node. Now, what we're going to do is we're going to say if the successor is not null pointer and the nodes, so the node, if that equals the node's value stored, the address stored in the successor's right pointer, we're going to have to do some work here. And I'll get into what that work is in the next kind of step through for the next condition. But if the node whose successor we're looking for is to the left of its parent, it's guaranteed that the next node in order would be its parent. So we don't need to do any more processing. We can just return the successor in this instance, because who is the successor in this case? The node with the key value of 12, and that's shown here. How did we arrive there? Well, remember what an in-order traversal does. So if we called in order on the node with 12, first we're going to process the left subtree, which would give us 10. Then we're going to process the node we're currently on, 12. And then we're going to go ahead and process the right subtree, 14, right? So notice that because this node falls in the left subtree of its parent, the left subtree, its parent is going to be its successor. So it's just, by kind of definition here. So what happens if it falls in the right subtree? So think about this. How do we do an in-order traversal of this? So we're going to start out, and let's assume it's recursive. We'll visit node 20. So we're going to have in order, let's call it 20. So we visit this node. First thing we're going to do, because remember, our in-order traversal is left, process node, right subtree. So in this case, we're going to process the left subtree. So we're going to go down here to 8, in order 8. We'll continue down to 4. We can't go left in 4, so we'll come back up to this activation record, process that node, attempt to go right. So we've gone left, we processed, attempt to go right, but we can't because it's a leaf. So now we're done with 4. We pick back up in 8. We've already done the left subtree of 8. So we'll process 8 and put 8 out. Now we're going to do the right subtree of 8. So in order of 12. So we're now here. First step is its left subtree. So go ahead and in order the node with 10. Notice that we can't step left because we're at a leaf. So we'll process the node and then attempt to look at its right subtree. Doesn't exist. So guess what? We're done with in order on 12. Okay, so now we're back to in order of 12, right? Sorry, we're done with in order of 10. We're back to in order of 12. We'll process 12 because we just computed its left subtree. So we process the node. Now we do its right subtree, 14. Now this is the node I'm interested in, right? Where is its successor? I don't mean to get ahead of myself, so let's do it out in long. So we're now at in order 14, can't step left. So we'll process the current node, can't step right. So now what are we going to do? We've processed the left subtree, we've processed the node, we processed the right subtree. We're going to return. Okay, we've already processed the node with the key value of 12's left subtree, that node, and its right subtree. So we're returning. Do you notice any kind of pattern here? Now we've processed the left subtree of the node with the key value of 8. We've processed 8, and we've processed its right subtree. So we're done there. Now we've processed the subtree of the node containing 20, and now we're going to process the node 20. Notice that 14 successor is the node with the key value of 20. So this seems a little bit complicated, right? Like it was easy in this condition where we had a node in the left subtree, and then the next node that we'd process is the parent, right? So in this case, it's left subtree. Guess who's going to be the successor to you? Well, the parent node. However, here we have the case where we're visiting 14 and it's in the right subtree of its parent. So its parent is not its successor. So notice here, parent cannot be its successor. Notice the successor cannot be 12's parent either. Why? Because look, this subtree of 8, the right subtree of 8 contains what? 14. Let me just highlight this. So here's our right subtree of 12. Let me draw this out 1 second. I don't mean to make this more complicated. Okay, so here's our subtree, right subtree of 12. here is 8's right subtree. And notice that the node who we're looking for its successor is in the right subtree. So the root of this, of the right the root node here, 8, cannot possibly be the successor to 14. Now notice here, we'll take one step up. In this left subtree of 20 contains the node we're interested in. Now in this case, guess who 14's successor is? 20, because we've just processed the left subtree, right? We processed pretty much all of those nodes. So who's going to come next after 14 in order traversal? The node with the key value of 20. So how do we compute this? We're not in this condition because the node's right is the null pointer. So we're down here. So we're going to go ahead and say successor. I'm just going to denote this as S so you can see how this is moving. Okay, our while statement is successor null pointer? In this case, no. Is the address of this node that node's right? So is S's right the node 14? It is. So notice what's happening now in the body loop. We're going to get into it because the conditional's evaluating to true. So here's what they're doing next. We're going to move node to the successor. We're going to move the successor up 1. Notice what this is doing. It's effectively checking each time to see whether or not the node that we were just considering as a parent is in the right subtree of the node we're currently considering as the parent. And in this case, the node storing the key value of 12's address is stored in the right pointer of S. So guess what we know at this point? We know we're still dealing with this instance where what's under evaluation is in the right subtree. And we need to keep going until it's in this left subtree, because only then will we have the condition that 14 is going to be less than the key value of the node under consideration. And that will happen when we go ahead and move this up 2. So now we have node pointing to that with the key value of 8, and the successor is 20. Is the successor not equal to null pointer? It's not equal to null pointer. Is the node's successor right? So is node's address stored in the successor's right? No, because the successor's right is not equal to node. It's the address of the node with the key value of 22. So notice what we've just accomplished at this point. We found the node that is going to be next in order after 14. So notice we don't hit the body at this point. We simply return successor. And successor is going to be what would come after the node with the key value 14 in an in-order traversal. So effectively, all we've done is we've kept stepping up. We kept looking at nodes in the next level until we found the case that the node under consideration was in a left subtree. So notice here, 14 is in the right subtree of 12. 14 is in the right subtree of 8. So 14 can't possibly be succeeded by 8. Can only be succeeded by 20, because at that point, guess what? 14 is in the left subtree of 20. And by our binary search property, if a node is in the left subtree of 20, it must be less than 20. So we finally arrived at the node who succeeds 14 in an in-order traversal.